We have talked about custom EVM precompiles since 2019, and we have made demos and technical prototypes for EVM precompiles in the Cosmos ecosystem for the past year. Our first public prototype demo of Quasar was in July 2022, and now we present you with a full implementation of Quasar. And in this video, you are going to understand the idea, utility, technical issues and solutions for implementing Quasar. And we are going to try out some demos on Mythos, a cutting-edge public blockchain that has adopted Quasar. This is our original idea and implementation, and we can make it available to any Cosmos EVM chain now. It is the first and at this time the only working version of Quasar. The Quasar concept is supporting a bidirectional flow of data and execution between the EVM and the Cosmos execution environment. Because the EVM is implemented as a Cosmos module, you already have access to the EVM from the Cosmos side. And Ethermint already has solved sending EVM transactions through the Cosmos side using wallets like Kepler. But Ethermint does not support access to the Cosmos context from inside the EVM. You cannot make a governance proposal from a smart contract. You cannot stake or delegate from a multi-sig. But Quasar makes all of this possible. Quasar allows the EVM to have access to both Cosmos transactions and queries through a Cosmos SDK precompile that we will call Quasar precompile. And both externally owned accounts and EVM contracts can use the Quasar precompile. For Cosmos transactions executed from an EVM smart contract like a multisig, Meta Cosmos transactions are triggered by an execution decision inside the EVM contract, and then the Cosmos transaction is executed, and then the execution outcome is stored in the EVM contract state. So now you can use any Cosmos module from inside the EVM, be it the bank module, governance, ERC20, IBC, Cron Epochs module, which were demoed in the past, eventual transactions also demoed in the past by us. Now, Ethermint does not synchronize Cosmos context with EVM context, and so Quasar needed to find an efficient way to keep EVM's in-memory StateDB changes in sync with the Cosmos context from inside the Quasar precompile, and also revert the Quasar-generated Cosmos changes if the corresponding EVM call frame was reverted, and also to assign the Cosmos precompile its own gas metering while in execution, after which the gas consumed is added to the EVM gas counter. To explain the frame nesting problem, on the left we have the global EVM execution context frame that keeps track of gas metering, state management, reverting state in case of an error, transaction management, and so on. The inner frame, the contract execution context frame, corresponds to a smart contract call or delegate call or static call, and it uses the global EVM functions, but also it has its own internal state, its own local variables. On the right, we have three nested contract calls, which means we have three nested EVM execution frames. This is where you have smart contracts that have internal calls to either external contracts or even themselves, but they use the delegate call, static call, or call code opcodes. And this is how things look like for Ethereum. Now let's see how things are for Ethermint. And in Ethermint, we start from a global Cosmos execution context frame. And inside, we find the global EVM execution context. And inside it, we will see each contract call execution frame. So Ethermint wraps the EVM execution in a Cosmos context. Now let's see what Quasar brings to Ethermint. We have the global Cosmos execution context, we have the global EVM execution context, we have the contract call frames, but now each time we call the Quasar precompile with a Cosmos message or query, we will have a corresponding Cosmos context frame. And this will be part of the EVM contract call where it originated. So the EVM ECF state needs to be synced with this Cosmos ECF. And if something in the EVM frame fails, then the Cosmos context must also be reverted. So this is how state management looks now in Quasar. And you can test Quasar on Mythos right now. Join our Discord to request Myth tokens for testing. And now I will show you some demos, and then we will talk about the solutions we used to solve the state nesting and synchronization issues. The first demo is showing you nested EVM calls with calls to the Quasar precompile, some of which revert with synchronized balance changes in both Cosmos and the EVM contexts. We are here in Remix and we have this contract named call self, which can make calls to other contracts and then also makes a call to itself and have a nested call frame inside. The call to itself is made with the lower level function call, which creates another inner call context frame that we have talked about. And inside, it receives an array of call data information, call data, and the contract address to call with that data. And it will make one call here and then a second call here, and the second call needs to succeed, otherwise this current call will fail, and then it makes a final call to itself again with the rest of the call data array and just logs the success or failure of this inner call. And we have several events here. For example, a context event that logs the balance of the contract itself and then the balance of the recipient, something that we give in this call info structure, and logging the gas available before or and after this inner call that we will use to call the Quasar precompile. So we can also look at what gas has the precompile call consumed. Also, again, log the balances of the contract and of the recipient after that call, log if the call was successful or not, and then the same thing for the second call, only that if the second call fails, we will revert this entire call, which will be caught here if it's an internal nested call. So if we revert an internal nested call, then the full wrapping transaction will not revert. It will succeed, but only part of that execution will be made. So this is what we will work with. And as called, the contract address will be the address of the Quasar precompile. The call data will be some Cosmos bank message send messages, and they will look something like this. So we will do the first 3 amounts should be messages that will succeed, and then the 4th message should fail. And because the 4th message fails, and it will fail because the amount that the contract will try to send will be too bigger than its balance. And if the 4th message fails, then we are in this condition. So then the 3rd message will also fail because the 3rd and the 4th one will be in the same call context frame. But the first 2 messages will succeed, and we should see this reflected in the balances, in the logs, and in the balances after the transaction is executed. And another thing here, we also modify the recipient's balance from inside the EVM prior to doing the precompile transactions. And this means we should see that this balance is also added and accounted for in the balance log after the precompile. So what we are going to do now is we are connected to the Mythos blockchain, and we are going to deploy this contract. The Mythos blockchain has chain ID of 7001, and we are deploying. Okay, we have a contract right now. We are going to copy its address, and we can also see this contract deployment in the block explorer for Mythos. We can see the contract was created. And now let's send it some funds. Okay, the transaction passed, and we can also see here 10,000, not Ether, but Myth. And this number is bigger than what we have here as balance in the contract. Okay, so what we're going to do now is copy this address. We will get the bec32 encoding of the address. So this is the contract that we've just deployed. And we need to create these message send Cosmos messages. And I have here a dApp in Mark's factory that will help me do just that. So we'll create the message send encoding from address. This is our contract address. The recipient is this address. And let's actually look in the Explorer and look at the recipient address to see what balance it has right now. And it has 0 tokens. So this will be a very clean cut example. And now for the first message, we'll have the denomination is a Myth. The amount is 1,000 units. And this will just encode, give us the encoding. So this is the Cosmos encoding, and this is the ABI encoding that we will copy here and provide as call data for our call. So as if we look at this structure, we need the recipient address, the address of the Quasar precompile, and then the call data. So this is the recipient address, this is the address of the Quasar precompile, and this is the call data. So let's do the same for these amounts. And we are constructing the messages with the smart contract that we just deployed that calls itself as the payer of these amounts. So think of that contract as, for example, a multi-sig that can send these Cosmos messages that can be governance proposals or staking or delegating or things like this. So now we've constructed our call data for this test with nested calls. And we are going back to Remix and use this call self with inner call function. Okay. We haven't copied the correct encoding. Okay, so we will need to quickly redo this because the ABI encoding always puts some zeros in addition, so we've been copying the Cosmos encoding. Let's start again. This is the message that we need to copy. Now we have the correct call data. We copy this and we paste it here, make the transaction, and the transaction was made. We can also see it in the block explorer. And we can see all the logs here. But Remix can show us the logs in a decoded way. So let's look at what we find here. Let's see what we should find. We should find a context log, which is this, which gives us our initial contract balance, which is this, and the account balance. So what happened before is the account received 7777 MITE tokens from this call, and we can see this reflected in the logs. The contract balance was subtracted and the account balance has received these tokens. Okay, now the next log should be a gas available log. We will move past this, another gas available log, and then our first precompile call is made with the amount of 1000. And we can see the account balance has increased with 1000. It's now 8777. The contract balance has decreased with 1000. And then we have a an inner call result, which of course was successful, and then a second call with the amount of 50,000. So the next one is the account has a 50,000 token units more than it had before, and this amount was subtracted from the contract balance. Again, an inner call result that was successful, which is what we expect. And then the rest of the two calls were made in a nested call. And we expect one of those, the fourth one, to fail, and therefore the third one should also fail. So that's why we only see one last log here with success false, because this inner call failed. So the logs reflect what we expect, and now we will look at the final balance, which for the account should be this. And we can already see here the final balance for the contract, which is what we expect. And the final account balance should be 58,777 and not more than that. And we will go here where we had 0 tokens. We will refresh the page. And this is what we get. 58,777 Myth tokens. You have seen a demo with nested EVM calls, with nested calls to the Quasar precompile, some of which revert because the wrapping EVM call context frame reverts, and synchronized balance changes in between the Cosmos and EVM contexts. In previous Quasar videos, you have seen Cosmos queries from the EVM and a Cosmos governance proposal triggered by an EVM contract. So what were our solutions? For Ethereum, I modified Go Ethereum, aligning the native precompiles to have the same interface and rights as normal bytecode-based contracts. And this was also talked about in a Go Ethereum issue. You can find my initial work on this branch. This is what enabled Quasar to be called from smart contracts and not only from externally owned accounts. In Ethermint, I built the Quasar precompile on top of the stateless precompile abstraction stub that was implemented in Ethermint by Federico Kunze. And then I efficiently synchronized Cosmos and EVM execution context frames. I aligned the Cosmos execution context frame to be reverted or committed to the final state by EVM's stateDB logic. And the Cosmos execution context frame can account correctly for the state and gas metering of all its children frames. Also, like any other contract or precompile, Quasar supports call, delegate call, which behaves like call in this case, and static call. And you can bring Quasar to your Cosmos EVM chain now. Quasar is compatible with Chronos, Inversed, Phantom, EOS, Kava, Evmos, Echelon, Berachain, Genesis L1, Canto, Bronos, Mythos. And if you don't see your Cosmos EVM chain here, let us know. What is next for Quasar? Access to Cosmos data from the EVM, but in an EVM ABI encoded format, to make it even easier for developers to build their Cosmos messages inside their smart contracts. Who wants to pioneer this for their chain?